So this is the lesson video for finding an inverse function. So first of all, let's figure out what inverses are. So when I think about the word inverse, what I'm thinking is the idea of something that is an opposite. So kind of like, what is the opposite operationally? So if I'm thinking about addition, the opposite operation of addition is subtraction. If I think about multiplication, the opposite operation is division. And if I think about square root, the opposite operation of a square root is if I think about the opposite operation of a square root, the opposite of that is essentially something squared. So what does it mean to take an inverse? Well, essentially what it means is if you combine two operations, they undo each other. So if you combine two operations, oh my gosh. So mathematically, what does it mean when you take an inverse? Well, what it means is if you do two operations, they cancel out. So for example, if I pick a number, 10, and I choose to multiply that number by 3, I then get 30. So they then end up with 30. If I then decide to divide that number by 3, I end up with the number 10. So what we're noticing here is that I started with 10 and I ended with 10. And in the middle, I did a multiplication by a value and a division by the same value, and essentially they canceled each other out. Okay? So it's the idea of the opposite operations and they undo each other. In the same way, if I pick a number, let's pick the 10 again, and I choose to square that number, I get now 100. If I then choose to square root that number, my resulting number, I get back to 10. So if I combine them together, such as 10, and then I take the square root of 10, and at the exact same time I square, what happens is the square and the square root reduce each other out, and I again am left with 10. And that's essentially why squaring and square root are inverses, because that's what they do. They reduce each other. Essentially, it's what you use to solve an equation. You apply the opposite operations until you get your solution. So what does it mean to take an inverse of a function? Well, if I'm looking at a function, what I'm saying is that essentially I have y equals an sum x equation. And I think about what's opposite. What is opposite is I need to essentially, so the idea is here, I want to switch the x and the y values. That's pretty much the main concept, okay? So notationally, if I'm talking about an inverse function, so I have the original function, so from f of x, and I'm trying to find the inverse. What I want to then say is f inverse of x. So please note that this little -1, all that means is, hey, I'm an inverse. So when you found your inverse set, that's how you write that you know it's the inverse, okay? All right, what does that mean on a graph? Well, what that means is that we just need to find your set, okay? So what are we doing? We need to switch the x and the y. All right, so this first one, I'm going to graph in green here. Okay, so this table is going to be a green table. So I'm graphing that in green. -1, 0, 0 and 1, 2 and 2, 4 and 5, 6 and 10. And essentially what I see is something, so that's my f of x. Okay, and I need to label it so I know that which is which. All right, so when I do the inverse, I switch. So I'm going to do this table in blue. So I switch the x and the y. So instead of -1, 0, 0, -1. Instead of 0, 1, 1, 0. 2, 2 remains the same. 4, 5 becomes 5, 4. 6, 10 becomes 10, 6. Okay? So 0, -1, 1, 0, 2, 2, 5, 4, 10, 6. Label this one with the inverse notation, f with the little -1 of x. So that says the inverse of f of x. Okay? And there we have our two graphs. Okay? So original set, x f of x, and new set, 0, -1. If you're doing this lesson for the first time, I'd recommend you pause the video right here and try the next set on your own so you can check to see if you're understanding properly. All right, so let's just do the same thing. Graph the first set in green. So 1, -6, -1, +1, -3, +2, -5, +3, -7, +10. So this graph is kind of looking rather cubic, honestly. Looks sort of like a cubic graph with that little jog in the middle. But anyway, that's my graph. So f of x, I've labeled it. Now I do the inverse. And how I do the inverse is I switch. So -6, 1, 1, -1, 2, -3, 3, -5, 10, -7. And then I graph those points. So -6, +1, 1, -1, 2, -3, 3, -5, 10, -7. All right, so looks like that graph is going right here. Okay, f inverse of x. All right, something you should note on these graphs is that they do intersect. It's not exactly changing the signs, okay? So positive values don't become negative values. You just switch the order, okay? So you're switching, essentially, you switch x and y is what you're doing, all right? So graphically, your inverse is, you've got a line of reflection, all right? And your line of reflection actually happens to be the y equals x line. So that's why right here your point is the same. So your line of reflection y equals x. Okay? So where your points are the same, like 2, 2, you'll get that same exact point on both graphs. All right? On your second graph, we didn't actually state this point, but we can see that there is a point where we have the same x and y value. Negative, it looks like negative 0.3, negative 0.3 about. Okay, so again, y equals x, line of reflection. Okay, essentially the way the graph works is you take your original graph. Let's look at the first graph. You take your original graph here, and you basically, if you consider this graph moving up, you pretty much turn it sideways. You flip it sideways over the line of reflection. So it flips, like if you use this as the fold line, okay, you should be able to see if you folded the original graph down along that line, you get the second graph. Same idea here. Here's my original graph. Okay, let's just look at the top part. So there's my top part of the graph. If I fold that along the line of reflection, I do see that this happens. So you can actually try this on a piece of paper if you wish. But if you have two sides of the graph, you want to think about each side separately. So there's the second side. I fold it along here. And yes, it does go up there. Okay, so that's what's happening for an inverse. Basically, you switch out your values. All right, so the last example was looking at it on a graph. We can also look at it graphically. Okay, so we're going to do our line of reflection. So line of reflection is right here. Y equals x. Okay, original graph is blue. So the easiest way for me to do this is write the original xy table. So I see the point -2, +5 on this graph. I see the point 0, -3 on this graph. For my inverse, so this is f of x, okay? My inverse being f inverse of x, xy, I switch my points. So -2, 5 becomes 5, -2. 0, -3 becomes -3, 0. Let's see, so -3, 0. Instead of being on the y-axis, it's now on the x-axis. 5, 2. The original graph was straight, so this graph is also straight. Oh, I can see I made a mistake. 5, -2. Okay. I will say that I could tell I made a mistake because if I draw my straight line, my second graph needs to cross the first graph on the line of reflection because that's my fold line. So that's how I could tell I made a mistake because I went up instead of going down. Okay. So let's look at the second one, f of x. Oh, forgot. First one, I should label f inverse of x. Second graph, xy point that I see. Let's see. I see stated on this graph in solid points, -2 and 10, -4 and 1, and -6 and -6. Okay, so that's my function. So my inverse set, before we do that, let's light the line of reflection. Y equals x. Okay, f inverse of x, supposed to be -1. Let me write that again because that's bad. So f inverse of x, I switch my points. So 10, -2, 1, -4, -6, -6. The last point is easy, -6, -6. 1, -4, 10, -2. So looks like my graph needs to go like this. The shape should be a little curvy because my original shape was curvy. And yes, there is my intersection point on the line of reflection.